So remember in 6.2, we're really thinking about this as our main equation. You can use this version for either sine or cosine. It's this idea that we have a sine of bx plus c plus d, where a, b, and c are our parameters, where a relates to the amplitude, b relates to the period, c relates to the phase shift, and d relates to the midline. So if you ask me to graph this thing from scratch, what I'm going to do is first I'm going to look at the amplitude. So I see that the distance from a midline to a peak appears to be 4. So if my amplitude is absolute A, then 4, that distance is absolute A, so A is 4. So that's why that goes here. Well, the period is always 2 pi over absolute B. Well, the period is just how long it takes to complete one cycle. So one way to think of it is from either a 0 back to a 0, or you can think the distance from peak to peak or valley to valley. In this case, we see that we go through one complete cycle from 0 to 0. It looks like we go from here to here. Well, it looks like that is negative pi and that is pi. So that total distance is 2 pi. So my period is 2 pi. Solving for b, I end up getting that b must be equal to 1. Here I went ahead and said that b must be positive because that's what they asked for. That's why I can drop these absolute values. So I now know that b is 1, that goes here, and a is 4. And so now I just have to find c. It should be pretty clear that d is 0 because the midline of this graph is at y equals 0. But to find c, we know that our phase shift is always negative c over b. So, we found that up here. Remember the way we found it is we said for our function, it wants to start at 0. So if we set the input to 0 and solve, we get that x is equal to negative c over b is where we want to start our cycle. So here, if we set where does this thing start at, the new starting value, it looks like here the first place to the left of 0 where we begin our cycle is at negative pi. So this is negative pi is equal to negative c over b. So solving, we already knew that b was equal to 1, so we get c is equal to pi. Similar sort of thing for the other one. So that's why c goes there, and that's our equation. For 44, it's the same sort of deal. Distance from a midline to a peak is 3. That's why a is 3. My period, or how long it takes to complete one cycle, here it seems like it might be easier to look from peak to peak. So I have one peak at 0 and one peak at 1. So it looks like my period is 1. So I replace that with 1. Solve for b and get 2 pi. So in my equation, I know that b is 2 pi and amplitude is 3 so far. All I have to do is find my c and my d. But since it looks like the midline is still at 0, I know that d is 0. Then to solve for c, I know my phase shift is always negative c over b. So I look to the left and find out where my first 0 was to find the smallest phase shift I could use. And in this case, it looks like the distance from a midline to a peak, that's one of our 4 steps. Well, since the entire period is 1, I know my step size is 1/4, so this point is negative 1/4. So my new start is negative 1/4. I already knew that b was 2 pi, so I can plug into the equation phase shift is negative c over b and solve that c is pi over 2. There's my equation. Next, they have, for an applied problem, they have this electroencephalogram. There's your word for today. And they just want to know, hey, what is the value of b? Well, we know that b relates to the period. And since period is 2 pi over b, I think if I can find the period, I can solve for b. Well, it looks like this thing starts here and does one cycle. And then it does 2 cycles in a distance of 1 second. So 2 cycles in 1 second means that the period it takes to make one cycle is a half a second. So period's equal to 1/2, and you solve for b to get 4 pi. Here again, we let b be greater than 0 just for simplicity. And then the next to last question would be this idea of heart action. This is just a sine curve where we've got our systolic phase and then our diastolic phase. We assume that below the graph, we've got some more of this sine graph, the other half of it. So it looks like half of the graph is from here to here. What looks like an entire cycle takes 1/2 a second, right? So because half of the cycle takes 1/4 of a second, it seems like the entire cycle, which is the systolic and diastolic phases together, 1/2 is an entire period. So that allows us to solve for b, which we put here. And then the amplitude is 8, because they told us that the maximum flow rate is 8 liters per minute. And so if this is the flow rate function, then its maximum is 8, and that's why that is. Cool. Last question. So on this last question, we've got tidal flow, and it wants us to sketch a graph. Well, they give us this, and then they tell us that a is equal to 0.5, so they just want us to sketch this sucker. Well, I know that period is 2 pi over b, so I plug in to get a period of 12, right? But step size is period divided by 4, so each step is going to be of size 3. We also know that our new start, one way to find our new start is to take our inputs, just to give you a different look at it. We take our inputs into the sinusoidal function, the sine of the cosine, and if you can factor out the number in front of t, that hands you b, and then this number that's left behind is the phase shift. So it's not c, because this is c, but if you just want the phase shift, you can factor that out, and you get 11 over 2 is the new starting value. So that's why this is where we start our cycle. And then since every step is of size 3, I can rewrite that as 6 over 2, so that when I start off at 11 over 2, I can take steps of size 6 over 2 every time to get all of my steps in my one cycle, right? I know that cosine starts at a peak, goes to midline, valley, midline, peak. I round it off at the top and the bottom. And since a is equal to 0.5, that means our amplitude is 0.5. All right. And that's it. Have a good one.